To summarize what is just in time is producing only what is needed and when it is needed. So with this kind of approach, the organization can eliminate the waste. And of course, the just in time is an integrated management system where during the implementation, all the element, all the element in the just in time need to be uh, conducted in parallel. So each of the element can support the implementation of the element. So in elementing ways, just in time, see that in organization there are a lot of ways to be eliminated. So some of the ways in the operation may include watching the machine run, waiting for part, counting part, overproduction. So there are many more ways in operation. So that's why in just in time, they didn't look only on the productivity to increase the productivity, but the ultimate goal in the just in time is to remove the waste the operation. So what we have here in the just in time, we have in general 10 element, basic element of just in time, which include flexible resources, cellular layout, full production system, Kanban production control, and so on. And all of these uh, element need to be implemented. Need to be implemented. It cannot be choose some of the element so to declare as a just-in-time system because it will not be successful. Each of element have uh, uh, have an output to support the other element to operating more efficient and effective. So the first element here, we have a flexible resources. Flexible resources consists of multifunctional workers and general purpose machine. What is the multifunctional workers? Multifunctional workers normally have a wide range of skills. So they have a multiple skill. They have a large knowledge about the numbers of activities, tasks to be done. So workers that have multifunctional workers that has multifunctional uh, skill and knowledge can be put at any other workstation to do the task given. So the second component under the flexible resources is general purpose machine. A general purpose machine means that the machine can work multi-function, So the workers only need to setting the machine to do the different operation. So organization didn't need to have many machine, so they can reduce the number of machine by having a general purpose machine to support their production process. Okay, in the just in time, Taishi Ono has a study on the uh, time taken by workers and machine to complete the activity in the task. So based on this observation on the time taken by uh, workers and machine, organization can improve in terms of efficiency and effectiveness of the uh, task done by the workers. So here we have how they note the operating time for each of the workers and for each of the machine. For example, here we have a pick up material activities, unload and load machine, and at the end of the process, we have inspect the pack. So the pink line here show the time taken by operator to finish a number of activities in the task, and the dash line here show the time taken by machine to complete a number of tasks. So based on this assessment and observation on the operating time by workers and machine, organization can have a better understanding of how to improve, to increase the efficient and effectiveness of the activities. So, based on this input, organization can also to have a continuous improvement on the process. On the other hand, organization may increase the flexibility by have a cell design. A good cell design must be arranged to respond the volume or design changes in the production. So another perspective to have a flexibility is to choose a better design of cell or workstation so that the workstation or cell uh, can respond quickly to the changes of volume or design, and applicable in office environment as well as production settings. Mean that the cell this layout of cell also can be implemented in the service sector, facilitate both product and process improvement. So to increase flexibility also, as mentioned in the previous slide, the need of the continuous improvement. Uh, the need of continuous improvement, whether in the design of the product and also uh, to increase the simplification of the process. So this also we have to increase the flexibility in the production process. And employees may be cross-trained for flexibility and efficiency. So to increase the flexibility and efficiency, of course, employee need to be trained. What you mean by cross-train is mean that employee we need to reshuffle. We need to reshuffle the position of the employees. For example, if you seen in our university, so the administration officer or clerk, when at the certain time of period, the university will reshuffle the position of our staff, university staff, to increase their flexibility and efficiency. Improve communication, facilitate the passing on important information about the process. And also, we need to consider about the communication element in the to increase the flexibility. So information must be passing with precise and quickly to the need, so that when we have a precise information, uh, the work that need to be done by workstation uh, can be more have can be more productive. With a little more inventory buffer, getting it right the first time is critical. So of course, employees need to do the task given at the right at the first time, because in the just-in-time implementation, the inventory buffer is very little, or some of the organization didn't allocate any inventory buffer to their production floor. The second cellular layout, the second element is the cellular layout. In the cellular layout, different machine, sorry, uh, in the cellular layout, we have a group of dissimilar machine. So this miller machine can produce a family of part. So because of the function of different machine, uh, only focus on producing the family of part. So it will involve a little setting or setup to the machine in order machine to produce a different function. Workflow in one direction through cell. So in the cellular layout, the workflow or the direction of input to the output is in one direction. And most of the just in time implementation or lean production, uh, the cell will arrange in U shape. The cell will arrange in U shape. So if we have a U shape layout, we have a U shape arrangement. We have a U shape arrangement of uh, process. We can we can scheduling our workers to respond to the changes of the volume by the customer. So the cycle time adjusted by changing workers parts. So for example, we have here cell in the cell one. Let's say we have a number of process here. How many process do we have here? 1, 2, 3, 4, 5. We have 14 process here in one cell. So let's say during this time, the volume is quite high. So we need to add more workers in this cell. When we add more workers in this cell, the workload for each workers will be decreased. And also the pace of completing the task also will be increased. So the time taken to complete, for example, here for the process uh, 1, 2, 3, 4, 5. So, for example, for workers one here, he might be can complete for the 5 tasks that given to him within the 10 minutes, for example, instead of doing uh, all the tasks in this cell. So by adding more workers, they can divide the task in the cell to increase the pace of the output by each of the process. And let's say the volume decrease, so we can only have one workers in one cell. So when we have one workers in one cell, the workers need more time to complete each to com- to complete all the tasks in the cell. So this is how in the cellular layout we improve the facility to respond to changes and changes in the volume and to increase the flexibility. The third element is the pull system. In the pull system, material is pulled through the system when it's needed. So this element explains that when workers need input to be processed at his process, so the workers only take what quantity and when to be processed from the previous workstation. So when the workers take the input from the previous workstation, and the workers at the previous station will notice that the there are no there are the output at the end of his process is need to be replenished. So the previous process also we start produce another output as a preparation to support the need of the next process. A simple example of the pull system we can see at the process of ordering ordering food at the cafeteria. And so some of the cafeteria provide a food, they cooking the food and put the food in the tray. So customer have a number of choice to be choose what they like to eat at that day. So this approach we can category as a push system. So the output has been produced before the demand occur. But in the pull system, the output only will be produced when there is a demand, when it's needed. So when you go to the cafeteria, you could request the order from the cafeteria, and the cafeteria only make what has been mentioned by the customer. So that approach we call as a pull system. So at the end of the pull system, we can prevent the over and under production. So there will be no shortage and no excessive inventory. But to implement the pull system, we need to force a cooperation between uh, producer and the customer. We need information, earlier information about what need to be processed and when to be processed. That's why in the just-in-time implementation, most of the manufacturer will share their production schedule with their supplier and distributor. So based on this production schedule, supplier will be more ready to respond to the quantity need and timing to deliver the uh, material or component to the manufacturer. And the fourth element is the Kanban production control system. Kanban in the Japanese words is called KAT. So meaning that Kanban in Japanese, Kanban in the Japanese word is KAT. So Kanban KAT indicate the standard quantity of production. So in the Kanban, we have a lot of information about the item to be processed. So this Kanban will be very informative to the workers. The Kanban production control system is derived from two bin inventory system. So just in time, adapt the Kanban system from the two bin inventory system to improve or to increase the apa tu to eliminate especially to eliminate or to reduce the need of large inventory in the production process. Kanban maintain discipline of full production. So mean that to implement the Kanban, the full system must be effectively used in the production process. So there are numbers of type of Kanban. Normally we have a production Kanban which authorize the production process, and withdrawal Kanban authorize the movement of goods. So withdrawal Kanban allow the workers to take the input or output from the previous workstation. So this is a sample of Kanban card. So what we have here, a lot of information that we can have from this card about the supplier, about the description of the item. What we have more? We have a production line where the item will be processed, and the uh, stock room number here. So very informative of Kanban card. And okay, we have here how the Kanban inventory system that derive from the two bin inventory system. So in traditional approach, we have two bin. In the two bin inventory system, we have two bin 1 and bin 2. Bin 2 act as quantity that demand during the lead time. Quantity demand during the lead time. So in the two bin inventory system, the reorder card will be placed at the bottom of the bin, at the bottom of the bin. So at the top of the reorder card, we have the item or input to be processed at the machine or workstation. So the workers will take the item one by one from the top. So when the item has when all the item has been used in the production process, the workers can reach the reorder card at the bottom of the bin. So this reorder card will be issued to the previous workstation as uh, to signal the previous workstation to produce output to support his workstation. So during the waiting time, during the lead time, the time between the order issue and receive the item, the workstation we use the inventory in the bin to process in the workstation. So in the two bin inventory system, of course, we need to have two bin. But in the Kanban inventory system, we only have a small lot of item placed or allocate at the every workstation. So this can reduce the work in process inventory in the production process and eliminate the waste occur in the production process. The Kanban inventory system, the reorder card, or we call it as a Kanban, placed at the top of the bin. So, before the workers take the item in the bin, the workers need to issue the Kanban to the previous workstation to signal the previous workstation to run the production process, replenish the inventory need by the next workstation. Okay, so this is the origin of Kanban. So, so this is the what we have in the first slide about the Kanban system, withdrawal Kanban and production Kanban. Withdrawal Kanban and production Kanban. So we start at note here 1, 2, 3, 4, and 5 and 6 here, right? So process B only produce the output based on the production Kanban. So if production B didn't have production Kanban, so process B cannot produce any output from this process. So let's say a process B have a production Kanban which authorize the process B to run the production process. And of course, process B need an input item or material to be processed. So to take this item, first the process B we issues the withdrawal process from the process A. So process B have a withdrawal Kanban which gives the process B authority to take the output from process A. So if the process B didn't have this withdrawal Kanban, process B cannot take the output from the process A. So when process A notice that the output has been taken by process B, the production Kanban will be issued to the process A. And to run the production process A will take the input from the previous process or from the store. So this process we repeat with the support, the implementation by pull system heavily based on the implementation of pull system. So the other type of Kanban, we have Kanban square, Kanban rack, signal Kanban, Kanban post office. There are lots of Kanban. Ini saya minta kamu baca sendirilah. Okay, determining number of combine. Let's say here we have, we need to determine the number of combine. So the formula is average demand during the lead time plus safety stock divided by container size. Simple formula for determine the number of combine. So let's say we have information about average demand 150 bottles per hours, and the lead time here is 30 minutes, and the safety stock is 10% from the average demand and lead time during the lead time. So the container size also we have 25 bottle. So based on this information, we will have a 3.3 combine or container need in the production process. So there are two consequences if we round up to 4 or down to 3. If we round up to 4, meaning that we will allow some slack because we have some excesses of inventory. And if we round down to 3, it signal to the production department to have improvement in their production process to avoid shortage during the production run. So another important thing in the determining the number of combine is to decide the size of container here. To decide the size of container here. For example, that we have here, the size of the container is 25 bottles. Alternative to choose or to determine the size of container, we can use formula for the production order quantity. We can use approach in the production order quantity where we determine the optimum batch size. So based on this approach of production order quantity, we can have an optimized quantity or size of container here. The next element is a smaller production. Smaller production will require less space and capital investment. So, and smaller production also can assist the arrangement of layout where the process, where we can move the process closer together. And of course, also in the smaller production, we make the quality problem easier to detect compared to the large lot. And also in the smaller production, the process can be more dependent on each other because we have only sufficient or little inventory or no buffer inventory in the production process. It will make the process more dependent on each other. So this slide show to us how the lot size is being reduced from 200 ordering quantity to the 100 quantity. So when the order size decrease, directly the average inventory also will be decreased. So we will reduce the inventory allocate in the reduce the quantity of inventory allocate in the production floor. We can use a EOQ analysis to calculate the desired setup time, and two key change necessary: improve material handling and reduce the setup time. So in the just-in-time inventory, inventory is at the minimum level necessary to keep operation running. And in the just-in-time inventory or small lot inventory, we use a pull system to move inventory, reduce lot size, develop just-in-time delivery system with supplier, deliver directly to point of use, perform to schedule, reduce setup time, and use group technology. And all of these uh, uh, action as a result of uh, reducing the uh, level of inventory. So when we're reducing the level of inventory, we need to aware to implement a numbers of uh, uh, approach and action in the production process. If we have a high level of inventory, there are numbers of problem in our organization will be hidden to be noticed by the management. Uh, Among the problem that hiding behind the high inventory level is lengthy setup, machine breakdown, poor quality, inefficient layout, unreliable supplier, and bad design. So when we reduce the level of inventory, all of these problems will be exposed to the management. So we will notice that this problem can have a significant impact or high impact to the operation of the production. And of course, it also we incur high cost of uh, uh, high cost in of process. Sorry. Okay. Next component in the next element in the just in time is quick setup. Is quick setup. In the quick setup, we need to understand uh, the biggest bottleneck in the production process. So there are numbers of component in the lead time, processing time, move time, and waiting time. But the setup time generally uh, generally uh, have a biggest uh, biggest what we say mm, biggest issues biggest issues that slow the movement of the material component to be processed in the production. So of course, setup time will be the big bottleneck to the production process compared to the waiting time, move time, and processing time. We need to reduce the setup time because it will directly also will reduce the setup cost. High setup cost will encourage a large lot size to be implemented in the production process. So in the just in time, we have a small lot size. So it is not matched with the implementation of just in time if we have a high setup cost, a high setup cost and setup time. So reducing setup cost also we reduce the lot size and reduce the average inventory. Setup time can be reduced through a preparation prior to a shutdown and changeover. To reduce the setup time, we can make a earlier preparation before uh, the shutdown of the machine and changeover activity. Okay, so why the why we need to why we when we reducing the setup time, we also can reduce the lot size and reduce the average inventory. So let's say the setup time for the machine at the earlier process is 30 minutes, and after the implementation of a quick setup, we can reduce the time taken to do the setup activity to the let's say 10 minutes. So from 30 minutes of setup time, we can reduce to the 10 minutes. So during the uh, at the previous setup time of 30 minutes, of course, the production process or workstation need to have a large buffer of inventory. With the large of buffer of inventory, the production floor need a large lot size that work as a inventory buffer to the production process. So when we reduce or we do the quick setup to the machine, this will allow the production process to allocate only a small lot size to support the production process. Approach to the quick setup is the single minute action die principle, where in the single minute exchange die principle, we need to separate internal setup from the external setup. So we need to identify what activity involved under the internal setup and what activity can be done under the external setup. So what is the internal setup and what is the external setup? Internal setup, the activity under the internal setup only can be done when the machine is stopped. When the machine is stopped. But for the external setup, we can do the activities while the machine is running. While the machine is running, we can do the activities of setup. So the second is convert internal setup to external setup by simplifying the process of the setup. Streamline all aspects of the setup, meaning that we need to identify what is the standard operating procedure or manual procedure to do the setup. We need to identify what the tool equipment need during the setup. We need to identify what is the first step to be done when we start doing the setup. So we look all of the activity need to be done during the setup. So this aspect will we allow workers more ready when doing the setup at the machine. And the last one is perform the setup activity in parallel or eliminate them entirely. So we can also identify or modify the setup activity so the internal and external setup can be done in parallel, or we can find other alternative way to eliminate the element of setup activity in our at our machine. So the common technique for reducing setup time we have here, for example, preset desired setting at the radio car using the quick fastener. So we can have fast apa tu fast process to attach or assemble the component. We have a approach locator pin like we use in the Lego block. We have for example here we have the operation like the cassette tape for the video tape here to prevent the misalignment. And numbers of example here, how do we reduce the setup activity and eliminate the setup activities. So the next element is uniform production. Uniform production level. Uniform production level only can be achieved from smoothing production requirement. From the smoothing of production requirement. Okay. Uniform production level can only be achieved from the smoothing of the production requirement. Changes in the final assembly of the production process often can have a significant effect on the component production upstream. When this happens in Kanban system, Kanban for certain part we circulate very quickly at some time and very slowly at others. So these changes can only be absorbed by the Kanban system at plus minus 10%. Plus minus 10%. So any changes at the end of the final assembly only can be handled by Kanban system plus minus 10%. So so to reduce the variability or changes of the uh, at the production line, there are numbers of approach. One, we need to have an accurate of forecast. So to avoid the last minute changes to our volume of production. Second is to reduce variability by uh, smoothing the demand, where the demand can be divided into small increment of time and spread out uh, evenly to the same amount each of the item uh, that produced for the each of it. And the third one is to have steady component production with mixed model assembly. So to have smoothing, another aspect to have a smoothing production level is JIT scheduling, where the schedule must be communicated inside and outside the organization. So we share about the production schedule with our uh, immediate partners, supplier and distributor. So to have a level production output, we need to process small lot size and freezing the schedule to have stability, where we avoid changes last minute to our production schedule, and also support with the Kanban system, where we use a full system to support our production process run smoothly according to the what is needed and when it's needed. So in the uniform production schedule, uh, there are numbers of action uh, need to be taken by production department to ensure the process runs smoothly, include the communicate schedule to supplier, make labor schedule, freeze part of the schedule, perform according to the schedule, seek one piece make and one piece move, which is uh, uh, eliminate waste, produce in small lot, use Kanban, the make operation produce a perfect part. So this is among the activities under the uniform production schedule. So to have a level schedule, we process the frequent small batch rather than a few large batch, and make and move small lot, so the level schedule is economical. Using approach of jelly bean scheduling, we that more responsive to the changes of the volume, freezing the schedule closer to the due dates, and that can improve the performance. So, example here we have level scheduling. For example, we have item A and item B, and the monthly quantity is 40 and 60, and uh, we can divide the demand into small increments of time for each and spread uh, and spread out evenly at the given time here. So from the monthly quantity 40, so we can divide into the daily quantity of 2 for the item A, and for the item B, we can divide from 60 quantity, monthly quantity of 60 to the daily quantity of 3. So this is how we leveling the production process to have a to have the level schedule. So this is another example of mixed model sequencing that we use level scheduling in the uniform production level. The next element is the quality at the source. There are numbers of approach and technique in the quality management has been adopted in the just-in-time implementation. For example, here we have a GDOCA, and then like under capacity scheduling, visual control, and Pokayokis. And we also have others quality approach like continuous improvement, Kaizen. We have Kaizen, we have quality circle, we have uh, SPC, statistical process control, and all of these quality approach and technique is very important to support the implementation of the just in time. So in the GDOCA, it's authorized the workers to stop the production line without permission of immediate supervisor. So the operator of the machine can stop the production line. And the light signal a quality problem. So each of the process will be install the ender light. So if the operator notice a quality problem at the process, uh, they will lighting the ender light. So the responsible workers like technician will be more easier to notice the process that have issues or problem. In the quality at the source also, the production schedule will be draw under capacity. This will allow for planning and problem solving and maintenance. Visual control used in the just in time to ensure the problem are more visible. While for the Okayoke, help the operator to prevent the defect occur in the production process. So the example of visual control that we have, this also visual control with the Okayoke, with the Okayoke. So the the ninth element in the just in time implementation is to have a sorry, the ninth element in just in time process is to have a total productive maintenance. In the total productive maintenance, we combine the preventive maintenance activity and total quality concept. In the preventive maintenance, the machine, the equipment will be inspected periodically. And also we have also the and also with the maintenance. So with these activities, we keep the machine operating in the long run. So this will help reduce the stoppages during the production process. Avoid the breakdown and to reduce the cost associated with the replacing part and component on schedule. So in the total productive maintenance requires management to design product that can be easily produced on existing machine. So the management didn't need to do the modification on the machine. Design machine for easier operation, changeover, and maintenance. So if the management to have a new machine, they must make sure that the machine is easier to be operated by the workers and easier to do the setup or changeover and maintenance. In the total productive maintenance also, we need to train and retrain workers to operate the machine. This approach will increase the efficiency and effectiveness of the workers in operating the machine. Purchase machine that maximize productive potential. When considering to purchasing the machine, the management need to analyze in terms of the utilization of forecast at, to the machine so that the purchase machine can be used with can be used in the long term run. So, and the last requirement for the total productive maintenance is to design the preventive maintenance schedule as to spanning the life of a machine. And the last element in the just in time is just in time partnership. Only exists when a supplier and purchaser work together to remove waste and drive down costs. The ultimate goal in the just-in-time partnership or supplier network here to remove the unnecessary activity, remove in-plant inventories, remove in-transit inventory, and improve quality and reliability of supply component. So under the supplier policy, the supplier need to locate near to the customer, use small side-loaded truck and ship mixed load, and consider the establishing small warehouse near to the customer or consolidating warehouse with other supplier if the supplier is at abroad, and use a standardized container and make delivery according to precise delivery schedule, and also to become a certified supplier which accept a payment at the regular interval rather than upon the delivery. So this is the supplier policy under the uh, partner relationship, and that's end our element in the just in time. So we conclude that the benefit of just in time, of course, there are a lot of benefit of just in time. We have can reduce the inventory, improve quality, and so on. So I think that's all for uh, just in time for today class. So before we ended our class this morning, any question regarding to the topic today? Okay, thank you. So we have another one chapter to finish our syllabus of inventory management. So after we finish our syllabus, we will make some review on the certain topic of uh, inventory management and also preparation to complete your assignment and task. We have a numbers of assessment need to be done. And before I forgot that we have a changes in terms of how the final exam will be conduct. How the final exam will be conduct. So I have a good news for you for the final exam. We will not have the structured question like a final exam in the hall, but we will have a multiple choice question, a set of multiple choice question, and also we will have an assignment, individual assignment that relate to the that apa saya nak cakap, that respond to the final exam assessment. That respond to the final exam assessment. We provide to you a case study, and based on the case study, you need to answer the question with the uh, limited time given to you. So, and also we have changed the assessment for the multiple choice question and the individual assignment. We back to you with the exact time and schedule for that activities in the group WhatsApp. Dr. Santra has informed me yesterday about the new schedule and new assessment that replaced to the final exam. So I will back to you with uh, more accurate information. Okay, that's all. Bagi yang beragama Islam atau Muslim, we end our class today with Surah Al-As.
Thank you, Doktor.
Thank you. Okay, siapa yang belum scan attendance, saya akan buka sekali lagi lah. Yang mana tak dapat, macam biasa masukkan dalam, saya lupa lah. Masukkan dalam grup WhatsApp.
Tiga, Doktor.
I